When you see it in the sky, it looks round, but the moon is more of an oval shape, similar to a lemon. This shape, flattened with a bulge on each side, came out billions of years ago when extremely hot tidal forces shaped its crust. They heated up some regions more than others. Gravity from our planet has helped to exaggerate this lemon shape over time. When they were getting ready to send missions to the moon, some researchers were worried because there was a thick layer of dust on the lunar surface. They were afraid seas of dust were both soft and thick enough to swallow their lunar lander. But even though the surface there is dusty, this layer is just too thin to cause complications. Our moon certainly isn't the biggest one in the solar system. The champion here is Ganymede, one of the 79 moons circling around Jupiter. But our moon is the largest in relation to its parent planet. It has a diameter of more than 2,000 miles, which is slightly bigger than the quarter of the size of the Earth. Pluto, for instance, has a smaller moon-to-planet ratio. Its biggest moon, Charon, is almost the size of Pluto, which is why it looks like a double dwarf planet system. How long would a walk around the moon take you? When the Apollo astronauts were there, they managed a walking speed of approximately 1.3 miles per hour. On average, you walk twice as fast down on Earth. The low gravitational force on the moon would give you significantly less traction on the ground. But those special spacesuits astronauts were wearing were never actually designed for long-distance hikes. In theory, you could maybe reach the speed of 3 miles per hour before you'd need to break into a run. At this pace, you travel 6,770 miles, which means making a circle around the moon in 91 days if you're walking non-stop. Why does the moon change its shape? It goes through different phases each month, starting from the new moon and gradually going to the full moon, just to do the same thing all over again, but in reverse. The sunlight hits one half of the moon at a time. This gives it a night and a day side, just like we have it here on Earth. The shape we see the moon in depends on where it's located compared to the sun. If it's directly between us and the sunlight only hits the side we don't see. That's a new moon. It appears completely dark in that phase. But when it comes to the far side of our planet from the sun, its day side completely faces the Earth. That's when we see a full moon. After the initial phase, when the moon is new, we'll see more of its surface in the sky as it orbits our planet. It's something we call waxing. The moon in this phase first becomes a crescent. The first quarter moon is when it's half full. After that, it goes into a gibbous moon phase, when it's larger than half full, but not yet full. After it reaches the full moon phase, it slowly shrinks and goes through the same phases but in the opposite direction. While up on the moon, you'd probably see human footprints there. True, no one has stepped there since the last Apollo mission in 1972. And the footsteps may stay there for many years because there's no geological activities on the moon, like earthquakes or volcanoes. There are no winds, rain, or other things that could erase these footprints. How would you get to the moon? Rockets are probably the first thing that comes to your mind, but a lunar elevator could be an even better solution, because traveling in a rocket would be a difficult, expensive, and pretty dangerous way to try to reach the lunar surface. Why would people want to go there? It's not just about craters, an amazing view of our home planet, or other unique things the moon offers. It's also full of resources like a rare form of helium. Humans could use it in fusion power stations on Earth. We could extract some other rare elements too, and use them for smartphones and other gadgets. For a lunar elevator, we need to stretch a cable anchored to the moon's surface for 250,000 miles towards the Earth. We wouldn't be able to attach it directly to our planet because both Earth and the moon are moving. But we could terminate high in our planet's orbit. We'd have solar-powered robotic shuttles that would move up and down the cable. This is like having a conveyor belt to ferry rare and precious resources our way. The cable would be as thick as a pencil and would weigh 40 tons. It sounds expensive, but a lunar elevator would most likely pay for itself within only 53 trips. The moon is in constant motion. It rotates on its axis and circles around the Earth, and it makes the same amount of time for the moon to make a circle around the Earth and rotate once on its axis, compared to our planet, which rotates on its axis every 24 hours, and makes a full circle around the sun in 365 days. So, the moon is tidally locked to our planet, which is why we always see the same side of the moon. One theory says the moon probably formed when a large Mars-sized object from our solar system hit the Earth. They collided 4.5 billion years ago when the solar system was still in its early stage, which was pretty chaotic. If this theory is correct, around 60% of the moon is made of lighter elements that are also present in the outer layer of our planet. A lucky set of circumstances lets us see total solar eclipses from our planet. The moon is the perfect size and distance from the Earth to appear the same size as the sun when we're looking at it in the sky. When the moon passes between the sun and us, it covers the sun perfectly. Plus, you can see an impressive halo that illuminates its edges. If it were any farther from us or smaller, a solar eclipse would only look like there's a blot on the sun. Our moon contains the water that kinda jumps around. There's water there locked up in ice. Some water molecules move around the surface as the moon cools and warms during the day. The water gets stuck on its surface until the lunar midday, when the sun is above the upper branch of any of the moon's meridians. At this point, some of the water melts, heats up, and ends up in the delicate lunar atmosphere. Its atmosphere generally contains some unusual gases, including potassium and sodium. Venus, Mars, and Earth don't have these in their atmospheres, so the water stays and floats there until it gets to a cooler area. Then it settles back to the surface. There's a specific anomaly under the surface of the south pole of the moon, a giant and extremely dense blob of metal lodged in the mantle. And, most likely, it's altering the moon's gravitational field. No one knows how such a huge blob of metal ended up trapped under the lunar surface. It could perhaps be remnants of the iron-nickel asteroid. 4 billion years ago, this asteroid crashed into the far side of the lunar surface and created this enormous South Pole Aitken crater. Our natural satellite is shrinking. Its interior is cooling, which results in the moon getting over 150 feet skinnier just as a grape wrinkles as it's shrinking down. But a grape has flexible skin and the lunar surface crust is brittle. That's why it breaks as the moon is getting smaller. That way, it forms thrust faults. One section of crust pushes over the closest part. This has been going on for the past few 100 million years. These lunar faults are still active. They probably produce moonquakes as the moon gradually shrinks and cools all the time. Some of these quakes are strong, maybe 5 on the Richter scale. During their orbit around the moon, astronauts took images of Ina, a quite unusual volcanic deposit. Ina is not that old. It might have been formed somewhere between 3.5 and 1 billion years ago. The volcanoes on the moon were probably active during the age of dinosaurs. If only they could have invented telescopes. They'd probably have a magnificent view of lava oozing from the lunar surface from time to time. The moon has its own time zone called Lunar Standard Time. It doesn't correspond with the time on our planet. A year on the moon lasts 12 days. Each day is about as long as a month on Earth. These days got their names after astronauts who walked on the moon. The days are divided into 30 cycles. The cycles are divided into hours, minutes, and seconds. The calendar started when Neil Armstrong set his foot on the moon on July 21st, 1969.
China's Yutu-2 is a robotic mission to the dark side of the moon, launched on December 7, 2018. On January 3, 2019, it completes the first ever soft landing on the lunar far side. It lands in the von Karman crater, not far from the moon's south pole. Scientists are interested in this area. Cold, permanently shadowed craters at the poles contain water ice. These ice patches are uneven and are likely to be ancient. In the south, most of the water ice is concentrated in craters, and at the North Pole, it's spread more sparsely. In any case, This ice can be used once a long-term manned mission lands on the moon. Anyway, several days after U-22 lands, it closes down its operating systems and hibernates through its first lunar night. It wakes up on January 29, 2019. All its tools operate normally. The rover travels 390 feet during its first full lunar day. One lunar day lasts for about 14 days, and a lunar night has the same duration. Moving and exploring during the day and switching off during the night becomes the rover's routine. It's the 8th lunar day when U-22 stumbles across something incredible. This discovery makes the scientists put off all other plans for the mission. They focus on figuring out what the strange material found by the rover is. In the beginning, this lunar day is no different from any other. It begins on July 25th, when the rover starts making its way through an area pockmarked with tiny impact craters. U-22 is helped and monitored by the driver team from the Beijing Aerospace Control Center. On July 28th, the team is preparing to shut the rover down for a midday nap. The sun is high in the sky. It means there are high levels of radiation and scorching temperatures that can damage the machine. Before powering U-22 down, the scientists are looking through the pictures taken by the rover's main camera. That's when they spotted a small crater filled with something that looks shockingly different from the surrounding landscape. Unable to identify the gel-like substance, the team orders the rover to check this bizarre finding. U-22 cautiously nears the crater to examine the weirdly colored stuff. The machine uses special equipment that detects the light reflected off the substance. It's supposed to help the researchers to understand the structure of the material. Unfortunately, the nature of the unusually colored finding has remained a mystery for over a year. No wonder that both the finding and the fact that initially there were no images of the enigmatic stuff sparked curiosity all over the world. The only available description of the substance was that it looked like a randomly colored, shiny gel, something that's rather odd for the dusty, arid surface of the moon. But finally, the mystery seems to have been solved. The researchers have analyzed the information received from the rover's equipment. As expected, the substance turned out to be made up of rock, greenish and glistening breccia, in a sample no larger than 20 by 6 inches. It's kinda like a geologic version of Jell-O salad with fruit inside. If you melt it down, it'll look glassy. Breccia consists of sharp stones joined together by a chalky substance. The sample found on the far side of the moon is made up of a mix of different minerals. The main is a type of silicate that's one of the most common components in both the moon and Earth's crust. The piece also contains some glass, which means it could have formed during a volcanic eruption. But volcanic activity on the moon stopped more than 3 billion years ago. That's why the researchers are almost sure it's unlikely to be the source of the unusual finding. The material could have been created by a massive asteroid, comet, or meteorite that once hit the moon. During the collision, the pressure and temperature were so high that huge amounts of rock instantly melted. Some pieces cooled down rapidly enough to form glass. The rest gathered at the center of the impact crater and grew colder more slowly, forming a new rock. The substance was likely not formed in the Von Karman crater, but in the nearby Finsen and Alder craters. The hollow where the rover made its finding was just 7 feet across. Whatever left it had to be no wider than an inch. But then, it would be too small to create such a large piece of breccia. It's interesting that the material is similar to the samples collected by the astronauts from NASA's Apollo missions. One of those samples was made of dark, broken shards of minerals glued together. It also contains some black, shiny glass. It's not clear, though, whether it's the same as the stuff discovered by U-22. When the rover took photos and made its measurements, it was rather dark in the area. The quality of the images isn't that great. The experts also explain that the mission is examining a previously unexplored area of the moon. That's why they don't have any samples from that region to compare them with the greenish, shiny substance U-22 found. But if their guesses turn out to be true, then the far side of the moon might have more in common with the Earth-facing one than we used to think. But what's so special about this dark side of Earth's natural satellite, and why can't we see it? It's all because of the phenomenon known as tidal locking. Earth's only natural satellite rotates around its axis once in 27 days. It's the same amount of time it needs to go round our planet. That's why you always see the same face. To be precise, 59% of the moon's surface is visible to people. It means that you can catch glimpses of the satellite's far side at some times of the year. The moon's side we can't see is quite different from the one facing Earth. It doesn't have dark spots that are visible at night. Those are lunar basaltic plains called lunar maria. They were created by ancient volcanic eruptions. Those happened about 3 to 4 billion years ago. Instead of plains, the far surface of the moon has countless craters and tall mountains. One of the ideas about such a striking difference between the two sides is based on the collision theory. It claims that billions of years ago, Earth collided with another planet or some other massive space body. After that, the debris from this collision crashed with something that would later form our moon. That's why the satellite's landscapes differ so greatly. A more recent theory suggests that the Earth-facing part of the moon is warmer because of the heat radiated by our planet. During the period of volcanic eruptions, it was cooler on the farther side. That's why the minerals there became solid faster. They formed a protective layer shielding the moon's insides against the meteorites. But each impact left an impressive crater. At the same time, a much softer crust on the front-facing side of the moon spewed lava every time a meteorite hit it. After this lava cooled down, it covered the impact craters. Even though the far side is often called dark, both sides get almost the same amount of sunlight. The side we see looks a bit brighter because of the glow coming from Earth. There are two reasons why people are interested in exploring the far side of the moon. After leaving our planet, many radio waves get blocked by Earth's natural satellite. If astronomers could build their radio and optical telescopes on the dark side, they would get much more data. There would be no problems with any kind of interference. The telescopes would also be shielded from the glare of daylight coming from our planet. If telescopes were set up inside craters, they would also be protected from solar radiation. Astronomers would be able to get an incredibly clear view of the far regions of the universe. Plus, scientists believe there are great amounts of helium-3 on the opposite side of the moon. Earth is protected from solar winds that carry this gas by its magnetic field. But our natural satellite doesn't have such a shield. That's why experts believe the moon can be a perfect place for helium-3 mining. This rare element can be later used as the fuel for fusion reactors. Okay, show of hands. Who still believes that the sun goes around the Earth? Nobody. Oh, but everybody used to. It sure looks like it does. The sun comes up in the east, the sun goes down in the west. The sun comes up in the east again, so the sun goes around the Earth. It seems intuitively irrefutable, and it is so. But it's not true. The sun doesn't go around the Earth. Everybody knows that, but only now. So why do people still believe the moon goes around the Earth? It's not true either. We have to go back over 500 years to begin to get an idea of how hard it is for science to change universally accepted facts. Nicholas Copernicus, around 1510, was the first to propose a heliocentric, sun-centered solar system. But he didn't do it publicly. Copernicus privately circulated letters to other astronomers explaining why the accepted fact of an Earth-centered solar system should be scrapped in favor of a more straightforward, more astronomically correct, sun-centered solar system. Copernicus's difficulty in promoting the sun-centered solar system depended on another bold conceptual innovation, that the Earth rotates. Copernicus's concept of a rotating Earth flew directly in the face of 5 literal statements in the Bible that the Earth was founded on a fixed foundation never to be moved. And the Catholic Church wasn't about to let that worldview be challenged or changed. Copernicus had too much to lose to go public with his revolutionary, pun intended, heliocentric theory, as a churchman himself. 100 years later, Galileo Galilei wasn't so reticent. Galileo had observational proof to back him up because he had a telescope. In early 1610, Galileo first observed the moons of Jupiter and kept track of their orbits. Yes, the moons of Jupiter do orbit around Jupiter. They go round and round the giant planet in actual orbits, unlike, as we shall soon see, how our moon travels around the sun with the Earth. Galileo became famous, or infamous, as the case may be, because he discovered orbital motions that were not heliocentric, that did not fit the accepted worldview. It rattled civilization's Earth-centered cosmology. Galileo was indeed revolutionary. Later in 1610, Galileo observed through his telescope, which only had an aperture of 1.5 inches, the planet Venus going through phases, just like the moon goes through stages. Galileo wrote that Venus imitates the moon, in Latin, in his notebook. There could be no other explanation for these observations. Venus was orbiting the sun. People were afraid to look through Galileo's telescope when he set it up in the Great Square of Pisa. They were too scared to have their worldview revolutionized. Strange as it may seem, we are experiencing something similar to that now concerning the moon orbiting the sun and acting like a double planet with Earth. People, scientists included, stubbornly persist in viewing the moon as its clever official International Astronomical Union name. It's a moon of the Earth, orbiting around the Earth, showing its different phases throughout the lunar month, or moonth, as moon fans sometimes like to call the 29.5-day cycle of lunar phases. Moon lovers' favorite day of the week, of course, is Moon Day. It comes right after Sunday. But back to the science. It's how our school books portray the phases of the moon. It's what people believe now. Notice how the Earth is the moon's center, and how it goes around the Earth in a circular path. This is the geocentric view of the moon. It's what we see from Earth. The moon comes up, the moon goes down. The moon comes up again. The moon goes around the Earth. But that's not what's happening in space. It's way past time we Copernicus-size the moon. We need to start seeing the moon from a heliocentric point of view, as we do for everything else in the solar system. First of all, the geocentric view of the moon's phases shows the Earth stationary, sitting in the center of the moon's path for a whole month. But the Earth is not stationary at all. We're zooming around the sun at a very high speed, anywhere between 66 and 68,000 miles an hour. Therefore, any picture of the moon going around a stationary Earth is profoundly misleading and really outright wrong. The heliocentric view of the Earth and moon moving together in space should look something like this. Notice that the moon is not going around the Earth. It's traveling along with the Earth, around the sun. The path of the moon around the sun is a sinusoidal path back and forth, across the ever-forward moving path of the Earth. Notice that the moon always goes forward too. It doesn't ever go backward to either the sun or the Earth. By always moving forward and sinusoidal, the path of the moon does not qualify as an orbit in the same sense that the other moons of the solar system orbit their planets in elliptical paths. Therefore, it is wrong to say the moon orbits the Earth. The moon orbits the sun along with the Earth, or the moon and the Earth both orbit the sun, are statements Copernicus and Galileo would approve of. But science today has difficulty accepting a heliocentric view of the moon. Maybe there would be too many books that need to be reprinted. Maybe too many astronomy professors would have to admit that they were wrong their whole careers. Accordingly, objections are put forward to block the revolutionary heliocentric view of the moon from being universally accepted. One such objection is that the moon never leaves the Earth's gravity well, and therefore should be rightly considered a moon of the Earth, an orbital, to use the astronomical term for satellite. Undoubtedly, the moon never leaves the Earth's gravity well, or else we would lose the moon. However, representations of this well-known definite fact always show the moon moving around the Earth inside the gravity well, and this is not true. The moon never goes back toward the Earth as it would need to if it were in an elliptical orbit. So the gravity well objection can be dismissed, because the astronomers who propose as orbital evidence that the moon always stays within the Earth's gravity well fail or neglect to include the facts of the moon's continuously forward sinusoidal motion. Escape velocity for the moon to leave Earth's gravity well is reported to be about 2,684 miles per hour. Relative to the Earth, the moon presently moves about 2,238 miles per hour. What kind of impact would it take to accelerate the moon that extra 450 miles per hour needed to knock it out of Earth's gravity well? If anyone wants to compute that, you're most welcome to put your answer in the comments section. Maybe it could happen, and that would not be good. There's another objection to looking at the moon from a heliocentric point of view, and that involves the barycenter of the Earth-Moon system. The barycenter is the center of gravity between the Earth and the moon. Think of yourself on a seesaw in the park. The other end of the seesaw is a massive lineman from a professional football team. How far forward towards you would the lineman have to move so that you both are balanced evenly? He'd have to move towards you almost to the center of the seesaw. You are the moon, and the lineman is the Earth, although Earth is a feminine name. The balance point of the Earth-Moon system, the barycenter, is over 1,000 miles inside the Earth. It is this balance point, astronomers dutifully point out, that is orbiting the Sun. It is a heliocentric point of view. Copernicus and Galileo would approve. However, these astronomers always seem to add the geocentric animation of the moon orbiting around the Earth, with the barycenter inside. In this way, they can keep the moon orbiting around the Earth. But it's somewhat dishonest to combine two different perspectives in one animation. You can't have your cake and eat it too. This leads us directly to the real sticking point that keeps us from believing that the moon is orbiting the sun, the double planet conundrum. The International Astronomy Union refuses to consider the moon and Earth a double planet. They refuse to do so almost exclusively because the barycenter of the Earth-Moon system is inside the Earth. It's tough to buck City Hall, as the saying goes. You'll recall that IAU, or UAI if you use the French designation, demoted Pluto to dwarf planet status, and they still haven't reversed that decision despite seemingly ample evidence that Pluto is the 9th planet. Perhaps we should reflect on what it means to be an Earthling. To be an Earthling implies that we know ourselves to be space-borne people orbiting a yellowish star near the outskirts of a spiral galaxy. We, meaning all the peoples of Earth, live in space and are absolute creatures from space. Above us is the moon, Earth's companion. We're making a big mistake by referencing the moon according to our geocentric parameters. Our conceptual expansion into space is inhibited by an incorrect, outdated, earthbound view of the moon. The universe doesn't revolve around us, and neither does the moon.